Hi all, in this video I am going to explain multiple choice questions and answers in electrical circuit theory. First problem, in a series RLC circuit, that is high Q circuit, the current peaks at a frequency. In a series RLC circuit, which consists of resistance, inductance and a capacitance connected in series. The condition for resonance is XL equal to XC. What is the impedance Z? Square root of R square plus XL minus XC the whole square. When XL equal to XC, the term get cancelled and Z equal to R. Z is very much small, so the current is large because I is inversely proportional to Z. I is large. Next, I am going to draw the diagram. In a graph, take F in x-axis and I in y-axis. First of all, I am going to draw the current waveform. Then Z waveform. Here the current is maximum at the resonant frequency. So, which one is the correct answer? Option A is the correct answer. Next problem. In a two-port network are connected in cascade. The parameters of the network are obtained by multiplying the individual ABCD parameter. When we multiply the individual ABCD parameter, then only we get the correct answer. So the answer is the fourth one, that is D. Problem number 3. In a pole zero pattern of a Saturn filter is shown in the figure below. The filter must be of the following type. See, in a filter that consists of poles and zero in both imaginary as well as real plane. Here 3 poles are available. One pole is -1, second one is -1 plus j and -1 minus j. And 3 zeros also there. The 3 zeros are Z1 equal to 1, Z2 equal to 1 plus j, Z3 equal to 1 minus j. And next I am going to write the H of S equation. K into S minus 1, S minus 1, then S minus 1 minus j, then S minus 1 plus j. And next in the poles also in the denominator I can write S plus 1, then S plus 1 minus j, S plus 1 plus j. And next I am going to multiply this. Here this is look like a minus b into a plus b form. So a is S minus 1, b is j. So S minus 1 the whole square plus 1. In the denominator also S plus 1, the same form, S plus 1 the whole square minus 1. Next I get k into S minus 1, S square minus 2S plus 2. Here S plus 1, S square plus 2S plus 2. Now look at this equation, S square minus omega naught of naught by q into S plus omega naught square divided by S square plus omega naught by q in the S plus omega naught square. So both the equations are almost same. So this is the second order all pass filter. So what will be the answer? The option C is the correct answer. Next problem. The necessary and sufficient condition for the rational function of T of S to be driving point impedance of an RC network is that all pole and zero should be. So all pole and zero should be in the negative axis of the S plane. So option A is the correct answer. Next problem. For a two-port network to be reciprocal. For a two-port network to be reciprocal, 4 conditions are given. When The Z parameter is reciprocal. Z12 equal to Z21. This is the condition. When H parameters are reciprocal, the condition is H21 is minus H12. If Y parameters are reciprocal, the condition is Y21 equal to Y12. And ABCD parameters are reciprocal, AD minus BC equal to 1. And here, which one is the correct answer? Y21 equal to Y12 is the correct answer. Next problem, for the compensated attenuator is shown in figure. The impulse response under the condition R1C1 equal to R2C2. Here, what is impulse response? Impulse response is H of S, that is equal to Laplace transformation of output to the Laplace transformation of input. So, which one is output? V2 of t is the output and V1 of t is the input. So, first of all, I am going to find out V2 of S. V2 of S, R2 of t and C2 both are connected in parallel combination. So, how to write? R1 R2 divided by R1 plus R2. R2 into 1 by C2S divided by R2 plus 1 by C2S. Now I have to simplify this. R2 by C2S divided by, take LCM, R2 C2S plus 1 by C2S. Both the C2S are get cancelled and get R2 by R2 C2S plus 1. Next, find out V1 of S. V1 of S is R1 into 1 by C1S divided by R1 plus 1 by C1S. Plus, I have to add this because these two are connected in series combination across V1 of t. So, R2 divided by R2 C2S plus 1. Next, I simplify the part number 1, R1 by R1 C1S plus 1 plus R2 divided by R2 C2S plus 1. And next I have to substitute the condition here, R1 C1 equal to R2 C2. If I like substitute the condition, R2 by R2 C2S plus 1 divided by R1 plus R2 divided by both the numerator denominator are same. R1 R2 C2S plus 1. Both the numerator denominator get cancelled and we get R2 divided by R1 plus R2, that is H of S. Next I am going to find out H of t. H of t is Laplace inverse of H of S. So what is Laplace inverse of H of S? R1 by R1 plus R2. Laplace inverse of 1, that is del of t. So the answer B, option B is the correct answer. Of the four network N1, N2, N3 and N4 are figure, the network having identical driving function point R. So driving function, we are going to find out the equivalent value, equivalent capacitance and equivalent resistance value here. So first I have to take N1. In a N1, the first these two are connected in series to 2s plus 1. In the Laplace transformation, how to represent this inductor, that is 2s. So 2s plus 1. And next 2 and capacitor, both are connected in series combination. How to represent this? 2 plus 1 by s. And then third one 1 by s. These three are connected in parallel combination. So what is Z equivalent? 1 by Z equivalent is 1 by 2s plus 1 plus 1 by 2 plus 1 by s plus 1 by s. So here 1 by 2s plus 1 plus s by 2s plus 1 plus s. Then take the LCM. So which one is common? 2s plus 1. So 1 plus s into 2s plus 1. So 2s square plus 2s plus 1. Here this is 1 by z equivalent. I am going to find out z equivalent. So inverse of this value, that is z equivalent, 2s plus 1 divided by 2s square plus 2s plus 1. And next take N2. In a N2, here two are connected in series, these two are connected in parallel. So 1 plus 2s, 1 plus 2s and here 1 plus 1, 2 plus 1s. here 2 plus 1 by s. Okay, both are connected in parallel combination. So 1 by z equivalent is 1 by 2s plus 1 plus 1 by 2 plus 1 by s. Here 1 by 2s plus 1 plus s by 2s plus 1, that is equal to, here what is the value? That is equal to s plus 1 by 2s plus 1. The inverse of this is 2s plus 1 by s plus 1 is the correct answer. And next n3. Here for n3, these are connected in 2 are parallel and this is connected in series with this combination. So 1 plus here parallel, no, so 1 into s divided by 1 plus s parallel 1 by s, that is equal to 2s plus 1, 1 plus s by 1 plus s, 2s plus 1 by 1 plus s parallel 1 by s. Parallel combination means 1 divided by 2s plus 1 by 1 plus s, that is 1 plus s by 2s plus 1 plus 1 by 1 by s, that is s. So 2s square plus 2s plus 1 by 2s plus 1, here that is 1 by z equivalent. I am going to find out z equivalent, that is 2s plus 1 divided by 2s square plus 2s plus 1. And the last one is 2 and 1 are connected in series. So 2s plus 1, that is connected in parallel with the capacitance 1 by s. How to write this? How to find out the z equivalent? That is 1 by 2s plus 1 plus 1 by 1 by s. Yes. Then what is here? Take the LCM. So 2s square plus s plus 1 divided by 2s plus 1. Now take the inverse of this, that we get the z equivalent. 2s plus 1 divided by 2s square plus s plus 1. So from this n1 and n3 both are same. So the option C is the correct answer. And next, the circuit shown in figure has a voltage source of V and current source of I and several resistors. The particular resistors are dissipate a power of 4 watt and V alone is active. The same resistors are dissipate the power of 9 watt when I alone is active. The power dissipated by R when both the sources are active. Here first of all I am going to consider V alone active. What is the equation for power? P is equal to I square R. P is given when V alone active, that is 4 equal to I square R. I have to taken as I1. I1 is square root of 4 divided by square root of R, that is 2 by root R. And then I alone is active. P is equal to I square R, 9 is equal to I square R, and I2 equal to 3 by root R. When both the sources are active, so I square into R. I square is I1 plus I2 the whole square into R. So first of all write 3 by root R plus 2 by root R the whole square into R. That is 25 by R into R, that is 25 watt. So which one is correct answer? Option D is the correct answer. And next, the network consists of linear resistors and ideal voltage source. If the values of all resistors are double, then the voltage across each resistor is. First of all, I have to consider the linear resistor and ideal voltage source. Here I am going to find out V1 and V2. How to find out V1? Using voltage division technique. Total voltage into the same resistance R1 divided by total resistance. In the similar manner, V2 is total voltage in the same resistance divided by total resistance. And next circuit, all the resistors are double. 2R1, 2R2, then voltage. Okay, here I have to take the voltages V1 dash. What is V1 dash? V1 dash is the total voltage V, not V1, the total voltage V into the same resistance. What's the same resistance? Same resistance 2R1. The total resistance is 2R1 plus 2R2. 2 here take 2 as the common. 2 get cancelled, so R1 divided by R1 plus R2. So not changed is the correct answer. Next problem. The two electrical subnetwork N1 and N2 are connected through 3 resistors are shown in figure. The voltage across 5 ohm resistor and 1 ohm resistor are given to 10 volt and 5 volt respectively. Then voltage across 15 ohm resistor. They have asked the voltage across 15 ohm resistor. So first of all, voltage across 5 ohm resistor is 10 volt is given, and voltage across that is for 1 ohm resistor is given. The middle one is not given. So first of all, I am going to write all the summation of all the current equal to 0. I5 plus I15 plus I1 equal to 0. What is I5? I5 is the voltage given 10 divided by 5 plus I15 the voltage is not given and I1 is 5 divided by 1. Now 2 plus I15 plus 5 equal to 0. I15 equal to minus 7 ampere. So minus 7 ampere, that is I15. So next I am going to find out V15. V15 equal to minus 7. Already the resistance is given 15 volt. Minus 7 into 15 minus 105 is the correct answer. Option A is the correct answer. Next problem. The number of independent loop of the network nodes, the network with n nodes and p branches is. The formula is L is equal to B minus N plus 1. Our next problem, the voltage VC1, VC2 and VC3 across the capacitor in the circuit in figure under steady state are respectively. Under the steady state condition, the inductance acts as a short circuit and capacitor acts as an open circuit. So I have to redraw the diagram. 100 volt 10k and here this open circuit 40k. Again one is inductor short circuit, then this is the open circuit, then 25k and 3 of the short circuit. First of all, I am going to find out VC1. VC1 is the voltage across the 40 kilo ohm resistor. I have to use the simple voltage division technique. So VC1 is 100 into 40k divided by 10 plus 40, that is 50k, that is equal to 80 volt. And next you have to take the parts separately. Here we are having the 80 volt, VC2 and VC3. First of all, I am going to find out VC2. VC2 is the total voltage, that is 80 volt into the same resistance or same capacitance, that is C2 divided by C2 plus C3. So C2 equal to 2 divided by 5 into 80, that is 32 volt, and VC3 also the similar 80, the total voltage into C3 divided by C2 plus C3, 3 by 5 into 80, that is equal to 48 volt. So which one is the correct answer? 80, 32 and 48, that is the correct answer. So option A is the correct answer. And next, the current I4 in the circuit of figure is equal to. See here, the current, this is I1 and this current is I7. So net current is 7 plus 5, no, that is 12 ampere. So ampere is the net current. My question is to find out I4. So I4 is the current that is opposite to this current. So what is the answer? The answer is option B, that is 12 ampere. Minus 12 ampere is the correct answer. Next problem, the network has 7 nodes and 5 independent loops. The number of branches in the network is. Here, how to find out the branch? First of all, I have to find out the loop equation, right? B minus N plus 1. How to find out B? B is equal to L plus N minus 1. So what is the answer? 5 plus 7 minus 1, that is equal to 11. So option C is the correct answer.